The opener for today asks you to solve a right triangle. When you see the directions solve the triangle, that just means find all the lengths of all the missing sides and the measures of all the missing angles. So in this particular example, we have two of the given sides. We're missing one side, which is labeled lowercase b, and we're missing angles A and angle B. So let's start with the missing side. Remember, in a right triangle, if you have two sides, you can always figure out the third side using the Pythagorean theorem. Now hopefully you've already tried this. You hit pause on the video, figure out the answer, and then you can play it back and make sure that your answer is correct. So Pythagorean theorem says b squared plus 27 squared equals 45 squared. And I'm going to need my calculator to figure out 27 times 27 and 45 times 45. But before I grab the calculator, let me subtract 27 squared from both sides. And then after I punch that in on my calculator, I'll have what b squared equals. So to find b, I need to take the square root of that answer. So I'm just going to punch all that into my calculator at once. Square root 45 squared minus 27 squared. And I get a perfect 36. So even though I had approximately equal to, we can actually write equals 36. So there's my first answer. This missing side is 36. Now I want to find my angles. Let's start with angle A. So let's use what we know about trigonometry to help me find angle A. Now it's a good idea never to use answers that you've just calculated to figure out the next answer. Because if I made a mistake finding side B, then I'm surely going to make a mistake finding angle A if I use that wrong answer from side B. So let me use the other two that were given to me. Now 45 is the hypotenuse of this right triangle. And for angle A, 27 is the adjacent side. So I have to think back to what I remember about sine, cosine, and tangent. So I need to use the adjacent and the hypotenuse. That means I want to use the cosine function. So I'm going to say the cosine of angle A equals adjacent over hypotenuse. Now I want to figure out what A is, so I need to undo the cosine. And the way I taught you in class to undo the cosine is we press on the calculator second cosine, and it gives us this. That means the inverse cosine. And then we'll type in the fraction for the inverse cosine. So once again, grab the calculator. And I want to make sure that I'm in degree mode, and I am. So I'm going to do second cosine to give me the inverse cosine. And then type in 27 divided by 45. And I get approximately 53.1 degrees. We'll round to the nearest tenth. It doesn't give us any direction about where to round, so we'll go nearest tenth. So 53.1 degrees. Now I need to find angle B. Well, I could set that up the same way. Now this would be the opposite side, and that's still the hypotenuse. And so I could use the sine function and solve it similarly. But that's way too much work. I know in a right triangle, all the angles add up to 180, but the two non-right angles should add up to 90. So I can simply do 90 minus 53.1, and that'll give me the answer for angle B. So angle B is 36.9 degrees. And there you have it. We have solved the triangle. We now have the lengths of all three sides, and we have the lengths, or the measures of all three angles. All right, let's go back and look over the homework which you were assigned last class. I'm not going to fill in all the answers for you, but I'll fill in some of them. So the first part, you just had to use a calculator and calculate the sine or cosine or tangent of the angles. So number one says, what's the sine of 32? So you punch in sine of 32. This one says round to 4 decimal places, so I'm going to say 0.5299. And then we do next one, the cosine of 25. 0.9063. Number 3 was the tangent of 58 degrees. 1.6003. And so on. So now you get the idea of how we calculate the sine or cosine or tangent of a particular angle. All right, in part 2, they're telling us what the answer is, but we have to find the angle. So that's where you use the inverse function. So I'll show you what I mean by that. For number 1, the sine of angle A is 0.1234. So what I'm going to do is press second sine to do the inverse of sine of the answer, 0.1234, and that's going to return to me the angle, whose sine is equal to 0.1234. So the angle is about 7.1. The directions here say round to the nearest tenth, so we'll go with 7.1 degrees. It's important to put degrees on your answers for these to remind you that we're getting back the measure of an angle. Let's do the next one. Cosine of angle A is 0.45. So I'm going to do second cosine, 0.45. And I get 63, and if I round it to the nearest tenth, 63.3 degrees. Let's do one more. Let's do number 5. The tangent of an angle, no, I'll tell you what, let's do number 6. The tangent of an angle is 8/15. So I'm going to hit second tangent, and now instead of typing in a decimal, I'm typing in a fraction, 8 divided by 15. And we get 28.1 degrees. All right, so there's your first two parts. The next 4 parts ask you to find the missing angle of the triangle. So let's take a look at number 1. We want to find the measure of this angle here, which is marked X. So in terms of that angle, let's label our sides. 25 is opposite, 15 is adjacent, and the other one is the hypotenuse. But notice we don't have a number for that, so we're not going to use the hypotenuse. We're only going to use the ones that we have numbers for. So for this angle X, I have the opposite and the adjacent. So once again, if you remember SOHCAHTOA, which one, the sine, the cosine, or the tangent, uses the opposite and the adjacent? Well, that would be the tangent. So I'm going to write an equation. The tangent of x equals opposite, which is 25, over adjacent, which is 15. Now this is just like what we did in the previous section. We want to find the angle. So to find what x is, I'm going to press second tangent to do the inverse function for tangent of 25 over 15. So we grab the calculator. And we're going to do second tangent, 25 divided by 15. And we get approximately 59 degrees. 59.03. This doesn't tell you what to round to, so generally with angles we're going to round to the nearest tenth. So we could write this as 59.0 degrees. All right, let's look at, let's do number 2. In this one, we want to find the angle again, which is marked x. So we're going to label our sides. 17 is the opposite side. 21 is the hypotenuse. So which one of the trig functions uses opposite and hypotenuse? That would be the sine function. So you write your equation. Sine of angle x equals opposite, which is 17, over hypotenuse, which is 21. So to find the angle, we're going to do the inverse sine, second sine, of 17 over 21. Grab the calculator. Second sine, 17 divided by 21. 54.0 degrees. And that's all there is to it. Numbers 3 and 4, similar. All right, so let's go to the next side. This says solve the triangle. And remember, that was like the opener. So you have to find all the missing pieces. So let's do number 1. We have 2 of the 3 sides. So let's find the side first, the missing side. So that's Pythagorean theorem. W squared plus 11 squared equals 14 squared. Remember, when you're setting this up, the hypotenuse is the one that goes by itself. The other 2, which are the legs, are the ones that get added together after they're squared. So it really doesn't matter where the variable is, it's which are the legs and which one's the hypotenuse. So once again, I'll grab the calculator, I'll do 14 squared, 196. I'll do 11 squared, 121. I'll subtract the 121 from both sides. And then I'll take the square root of that answer to get what W equals. So W is going to equal the square root of 14 squared minus 11 squared. Is approximately 8.6602 or 03. They don't have specifics here, so for sides, let's go 2 decimals on this. So 8.66. So there's our first answer. Now let's figure out one of the angles. Let's do angle X. Now remember, I don't want to use my answer for W in case I made a mistake. So let me use the 11 and the 14. 14 is your hypotenuse, and 11 is your adjacent leg. So adjacent and hypotenuse. That would be the cosine function. So we're going to say the cosine of angle x is equal to the adjacent over the hypotenuse. So to figure out the angle, we're going to use the inverse cosine, second cosine on the calculator, of 11 over 14. Second cosine, to give us the inverse, 11 divided by 14. 38.2 degrees. So now we have that angle. And to find angle y, we'll just subtract angle x from 90. And that gives you y is equal to 51.8 degrees. And now you have solved that triangle. Number 2 is the same idea. They don't have letters, but you can use any variables you like. Find the missing side. If you want, maybe call this w again. Call one of the angles x. Call the other angle y. And solve it in a similar manner. The last two problems are just solving for one specific side. So let's say we want to do number 1. We have an angle here of 58 degrees. Let's label the other sides. Your hypotenuse. This is opposite from the 58. So we have opposite and hypotenuse. That's a sine function. So sine of 58 equals the opposite over the hypotenuse. We've talked about in class how to solve these. So that's the same equation as saying x is equal to 15 divided by sine of 58. Remember, sine of 58, if you punch that in on your calculator, it's just a number. It's a long continuous decimal. It goes on forever. So we want to do 15 divided by that number. So, grab the calculator. And let's do 15 divided by sine of 58. And we get side x is 17.7 degrees if I round it. I'm sorry, 17.7 in length if I round it. So 17.7 for x. And that's units. Similar idea for number 2. Hopefully this has helped with your homework and you've checked and taken the time to go through and listen to my explanations on these if you weren't sure. And now you should be ready to solve some triangles on your own.